I really like this. It says Plate Tectonics, a Paradigm Under Threat. It was written by David Pratt in 2000. There's the front of it. I went ahead and printed this out, and I struggled to read all of it in one sitting when I was at Barnes & Noble. But I got through it and I highlighted a few things. The abstract basically lays it down. I'll go ahead and read that out to you. This paper looks at the challenges confronting plate tectonics, the ruling paradigm in the earth sciences. The classical model of thin lithospheric plates moving over a global asthenosphere is shown to be implausible. Evidence is presented that appears to contradict continental drift, seafloor spreading, and subduction, and the claim that the oceanic crust is relatively young. The problems posed by vertical tectonic movements are reviewed, including evidence for large areas of submerged continental crust in today's oceans. It is concluded that the fundamental tenets of plate tectonics might be wrong. Might be basically, he means they're wrong. The fundamental tenets of plate tectonics are incorrect. First page, here we go. It has been said that, quote, a hypothesis that is appealing for its unity or simplicity acts as a filter, accepting reinforcement with ease, but tending to reject evidence that does not seem to fit. Meyerhoff and Meyerhoff, 1974, page 411, that's in the references at the bottom of this, argued that this is, quote, an admirable description of what has happened in the field of Earth dynamics, where one hypothesis, the new global tectonics, has been permitted to override and overrule all other hypotheses. It's from Nitecki et al., 1978. Actually, this is from Nitecki et al., 1978. Reported that in 1961, only 27% of Western geologists accepted plate tectonics, but that during the mid-1960s, a chain reaction took place, and by 1977, it was embraced by as many as 87%. Some proponents of plate tectonics have admitted that a bandwagon atmosphere developed, and that data that did not fit into the model were not given sufficient consideration, resulting in a somewhat disturbing dogmatism. McGarry and Plummer, 1998, acknowledged that, quote, geologists, like other people, are susceptible to fads. Sorry, I couldn't pronounce that word. Basically, it's the same thing that happened with Big Bang. It's a big fad. The universe coming from something the size of a watermelon and creating all time and matter. It doesn't make any sense to me. It's a fad. It's a pseudoscientific fad is what the Big Bang is, and plate tectonics was a fad as well, and it's still somehow the foundation for geology, which is really strange. Especially after reading this, so I'll go on some more. Saul, in 1986, pointed out that no global tectonic model should ever be considered definitive, since geological and geophysical observations are nearly always open to alternative explanations. He also stated that even if plate tectonics were false, it would be difficult to refute and replace for the following reasons. The processes supposed to be responsible for plate dynamics are rooted in regions of the Earth so poorly known that it is hard to prove or disprove any particular model of them. As well, the hardcore of belief in plate tectonics is protected from direct assault by auxiliary hypotheses that are still being generated. That's the peer review process. They reject any other alternatives as well. And the plate model is so widely believed to be correct that it is difficult to get alternative interpretations published in the scientific literature. So basically what happened is the bandwagon effect took over in the mid-60s, 70s rolled around, and all of a sudden they started to make sure that nobody else had any alternative explanations for it. And if there were any alternatives, they rejected them immediately and made sure none of it was published in academic journals. Peer review process at its finest. Page 3. Despite the compelling seismological seismographic, I think that's how you say it, evidence for deep continental roots. Some plate tectonicists have suggested that we just happen to live at a time when the continents have drifted over a colder mantle. But then again, it's readjusted in here where he says, seismic tomography has merely reinforced the message that continental cratons, especially those of Archean and early Proterozoic age, are welded to the underlying mantle, and that the concept of a thin, less than 250 kilometer thick lithospheric plate moving thousands of kilometers over a global asthenosphere is unrealistic. Because when you think of the deep continental roots inside the lithosphere, stretching all the way down past 250 kilometers, how is something like that supposed to move from side to side? It's going to get in the way of everything. How does that happen? How does a continent smoothly roll, I guess you could say, over this jello-like mantle? Nevertheless, many textbooks continue to propagate the simplistic lithosphere-asthenosphere model and fail to give the slightest indication that it faces any problems. Basically what we have here is it says, thus the lithosphere has a highly complex and irregular structure. Far from being homogeneous, plates are actually a megabrachia, a pudding of inhomogeneities whose nature, size, and properties vary widely. So essentially what they're saying there is, if you have a plate that's made up of a whole bunch of different types of rocks and minerals in varying layers, how does something moving against something else explain how those layers get there if they only moved in one direction the entire time? How did they get there to begin with? It's too complex to explain inside of a simplistic model, in other words. But basically, I think that's why it became popular, is because it was so simple that people just accepted it without any further thought. And it's very dangerous. Also, it holds power for new theories such as my own. If it's really simple, people will immediately accept it. But I have to watch out for that too, because there's a lot of things that I could be wrong concerning the theory development. But I'm looking for them. Believe me, I know there's a lot wrong with it. There's a lot of work to do. See, page 4 here. Alright. See, rift zones. Those are from my notes. Page 5. Okay, here's another thing that stuck out to me. Inside of this paper, David Pratt likes to stress the fact that since there's a bandwagon effect, everybody, jumps on the same bandwagon and they all go in the same direction. What happens is it doesn't pay off to consider alternative explanations, and you sort of have to ignore any disconfirming evidence, especially if it doesn't fit with the paradigm. The paradigm holds precedent. You can't rock the boat anymore because everybody has all this other information that supports it over here. And if you have this little bit of disconfirming over here, then it's just rejected. But that's what's come of geology, is it doesn't matter how much disconfirming interpretation and evidence you have, it doesn't get considered at all. They push it out of the way. But basically he says here, several major submarine structures that appear to be of continental origin are ignored in the Bullard, Everett, and Smith fit. This is the Bullard, Everett, and Smith fit, where they have these continents supposedly fitting together. Notice how Mexico is missing, and that little black area between the two are the overlaps and problems as to why they don't actually fit with each other. Where's Mexico? Where's the Caribbean? Where's all that landmass? They just ignore it. They say, look, it fits like this, and then basically it's just confirmation bias. They take seemingly fitting things and they put them together, and they're supposedly, this is how it works. No, it's not how it works. Especially since if you have two land masses going in this direction, what about the back half of the Earth? Where's the big suture where the mass is coming out of. It doesn't add up. But yeah, that's my interpretation of it. But continuing on, this is page 5. This means that any reconstructions based on arbitrarily selected depth contours are flawed, given the liberties that drifters, the plate tectonics proponents, have had to take to obtain the desired continental matches. Their computer-generated fits may well be a case of garbage in, garbage out. So basically, they just take what appears to be and they try to mash it together. When in reality, it doesn't work like that. You can't just mash things together. Think of like a puzzle where the pieces, they look like they should fit together. So what you do is you take a hammer and you hit the pieces together. If the pieces don't fit, they don't fit. And that's basically the main problem with this plate tectonics, is that they don't actually fit. It was just confirmation bias all the way. There's problems with the paleomagnetic discontinuities. I'll go ahead and find the page that has that on there before it gets too dark and you can't see anything. Where is it at? This is a lot of material. Oh yeah, here's the drill, the cores data on the core data when they drill down into the ocean floor to find how old the material was. That's interesting. They ignored a lot of the disconfirming evidence for that. Oh, here it is. Okay, you have the textbook cartoon on top, and you have the actual magnetic anomalies. This is Iceland, Scotland, and Scandinavia on the right. So there's the textbook version where it's, supposedly perfect. And then you see what the actual magnetic anomalies look like. Anomalies. Like, how do you explain that? You can't. What it means is that they took one specific thing where it looked like it was the poles reversing direction, which was caused, as the mid-oceanic crust pushed its way outward, supposedly, that the magnetic field was flipping back and forth as it was going on. But how do you explain that? How do you explain that with a flipping pole and having it really neat? Clearly there are discontinuities there that aren't related to any type of pushing crust kind of model. But anyways, I think that sums up this talk. I'll go ahead and link this to the bottom of the page. Today is September 12th, 2016.